In this video, we will be solving a few sums from angles and measurements, and these sums I have taken them from the Maharashtra government textbook from the miscellaneous exercise 11th standard maths part 1. Okay, so let's get started. Find the number of sides of a regular polygon if each of the interior angle has the measure of 3 pi by 4. I am not very comfortable in dealing with radians, so I will prefer to convert it into degrees and then go ahead. Pi by 4 radians, I know that is 45 degrees, and 45 into 3 will give me 135 degrees. So that's the interior angle. So the exterior angle would be 180 minus 135, that is 45 degrees. If the exterior angle is 45, then measure of every exterior angle was given by 360 upon n. So if you just cancel off 45 and 360 here, 45 into 2 is 90 and 90 into 4 was 360. So 45 into 8 would be 360. So the value of n turns out to be 8. So the number of sides in this regular polygon is going to be 8. So the answer for your first question is n equal to 8. The number of sides are basically equal to 8. Go ahead with the second one. There are two circles each of radius 7 centimeters which are intersecting each other. Okay, so that's one circle and that's the other circle. Both are of radius equal to 7 and they are intersecting each other. Fine. The distance between their centers is 7 root 2. Okay, so that tells me a lot about what the circles are going to behave like, or the diagram is going to be like, because this is 7, and this is already 7 root 2. The length of this line joining their centers is 7 root 2. So you can very clearly see that 7 square plus 7 square is going to be 49 plus 49, that is 98, which is equal to the square of the third side. So the Pythagoras theorem getting satisfied, you know that this angle out here will be 90 degrees. Let's read the question further. Find the area of the portion common to both the circles. So we need the area of, okay, let's rub out this extra things that I've written here. Okay, so we need the area of this part, right? Let's do one thing. Let's divide that area into a total of two equal parts. That is, let's draw a vertical line right here. And I'm dividing that area in two parts, half of which is this. We will try to compute area of half this part and multiply that with 2 to get the required area. So this part, now say for example I complete my triangle here. The area of this part, I'll just draw that triangle once again. If I just call it OAB, the triangle OAB will look like this. And the sector OAB looking like this. Okay, we need this area. This being 7, this being 7. We don't know what the measure of this angle is going to be. So let's just draw that thing again. We knew that this length was 7 root 2. So this angle was 90 degrees at the top. The two radii are equal, that is 7 and 7. That tells you that the angles here and here are 45. If I am drawing this radius, then even this angle is going to be 45 degrees because the same diagram is what you have on the other side. Like the diagram is symmetric, so both these angles, that is, both these angles means this angle here and this angle here, both of them are 45 degrees. So the total angle here is 90 degrees. So this angle here, precisely if I have to draw it, I would say it is this. Okay, so 90 degrees. So the central angle being 90, I just need the area of this part. The area can simply be obtained by taking area of the sector minus area of triangle. Area of the sector will be half r square theta minus area of the triangle, that is half r square sine theta. For all those who are not aware about this formula, I have made a separate video on length of arc and area of a sector wherein I have discussed this particular formula. So do check out that video in case if you are not able to understand this, and if at all you are able to understand it in one line, then the formula is half multiplied by the product of any two sides multiplied by sine of the angle between the two sides. So here the radius is 7, r square would then be 49, theta is 90, but I need to write that in radians, so that would be pi by 2. R square, like I said, is 49, sine theta would be sine of 90, which is equal to 1. So if you take out half and 49 common, you get 49 by 2 into pi by 2 minus 2. Pi by 2 minus 1. That's the area of this sector. This is equal to this much area. But if you remember the question, our area was twice of this. So our required area would be twice of whatever we have just got here. So that twice of whatever we have just got would be 49 into pi by 2 minus 1. So this represents the required area, and that's the answer for the second question. Okay, let's go ahead with the third one. It says that triangle PQR is an equilateral triangle with a side of 18 centimeters. Okay, a circle is drawn on the segment QR as the diameter. So here's the triangle PQR. And you're drawing a circle with QR as the diameter. Now, if this is PQR, a common misconception is that the circle with PQ as diameter would look like this. No, it wouldn't. If you draw a circle with QR as the diameter, it is going to look like this. It is going to cut the other two sides of PQR also. Okay, so that's the circle with the midpoint here being the center. The length of side is 18 centimeters, so this much length would be 9. Okay, let's call the center as O and read the question further. Find the length of arc of this circle within the triangle. So within the triangle, the arc I have is this. This is the arc which I have within the triangle, and I need the length of this arc. But to get the length of that arc, I basically need the value of the central angle here. Because if I know this angle, I can get the length of arc as S equal to r theta, and radius of this circle which I have drawn is equal to 9. Okay, so radius is 9, all I need is theta. So we know that this is an equilateral triangle, which means this and this, both of them would be equal to 60 degrees. This and this represents area of, the radius of the same circle. So this angle and this angle, they will be equal. In a similar way, this and this also represent the radius of the same circle. That is why this angle here and the angle here will also be equal. All of them are therefore equal to 60 degrees. If this is 60, this is 60. The third angle of the triangle will also be 60 degrees. If this is 60, this is 60. Again, the third angle of the triangle, which is this, is also 60 degrees. This entire angle is 180. So this central angle theta is also 60 degrees. So when I put theta as 60 degrees, I actually have to put it in radians, right? So 60 degrees in the form of radians would be 60 into pi upon 180, that is pi upon 3 radians, and finally I have the length of arc as 3 pi. Okay, so the length of this pink arc, that is the length of arc intercepted inside the circle, is going to be 3 pi. Because the length has been given to us in the question in centimeters, we will write the length of arc as 3 pi centimeters. Okay, so I hope you are clear with that question. Let's go ahead with the fourth one. It says find the radius of the circle in which the central angle of 60 degrees is intercepting an arc of 37.4. So here's a circle. Okay, the central angle is 60 degrees and the length of arc intercepted between the two lines is 37.4 centimeters. We use the formula S equal to r theta, S being 37.4. R is what we are trying to find. Theta is 60 degrees in the form of radians. 60 in the form of radians, we just calculated that was pi by 3. And we will prefer to put pi as 22 upon 7. So we have 22 here and 7 here. Does 22 cancel 37.4? Let's check. 22 upon 11. 22 upon 11, that would be 2. And 37.4 by 11, it would be 3. Then a point and 44. So 4. Yeah, it does get cancelled. 2 cancels of 3.14 and you have a 1.7 on the left. 3 into 7 would be 21. That 21 also goes on the left. And we finally get the value of R as 1.7 into 21. 1.7 into 20. That would be 34. 34 and 1.7 would make it 35.7. So the radius is 35.7 because all the measurements are given to us in centimeters. I'm sorry, it's the fourth question because 37.4 was given in centimeters. We have this radius in centimeters only. So the radius of this circle would be 35.7 centimeters. Take the next question, the fifth one. It says that a wire of length 10 centimeters is bent so as to form arc of a circle of radius 4 centimeters. What is the angle subtended at the center in degrees? It's a very straightforward question. The length of wire is 10 centimeters and you are bending it to form arc of a circle. So this is 10 centimeters. The arc of the circle is having the radius as 4 centimeters. Okay, I know not a very accurate diagram, but okay, it does serve the purpose. What you need is theta, but you need that in degrees. So we can use S equal to R theta. S being 10, R being 4. We have theta as 10 upon 4. That is 2.5 radians. And 2.5 radians, if you want to convert an angle in radians to degrees, you simply multiply that angle with 180 upon pi. So we have the angle in degrees as 2.5 into 180 upon pi. That's 25 into 18. That's 25 into 18 would be what? 50 into 9. So 400 and 450. So 450 upon pi. So the angle in degrees would be 450 upon pi degrees. You can definitely write pi as 22 upon 7 and try to cancel it as much as possible. It's okay if you don't do it and leave it right here. So the answer for this question, the fifth one, is 450 upon pi degrees is the central angle. Let's go ahead with the sixth one. It says if two arcs of the same length is telling us S1 is S2, in two circles are subtending angles of 65 and 110 degrees at the center, find the ratio of their radii. We begin with S1 equal to S2. So we know that R1 theta 1 is R2 theta 2. R1 into theta 1. You need to write theta 1 in terms of radians when you are using the formula R theta. So theta 1 in radians, they have given the angle in degrees, which is 65. So to convert that into radians, we multiplied with pi upon 180. On the right hand side also, we will write that theta 110 as the angle in radians, that is 110 into pi upon 180. But here you definitely observe that 180 and pi get cancelled on the left and right. So you are ultimately left with R1 upon R2. You're bringing that R2 in the denominator of the left. So R1 upon R2 would be, on the right you have 110 divided by 65 goes on the right. So 110 upon 65, that would be what? 22 upon 13. And yeah, that's the ratio of radii of the two circles. So that's the answer for question number 6. Let's go ahead with the seventh one. The area of a circle is 81 pi centimeter square. You need to realize that area is always given by pi r square. If they are saying that area is 81 pi, pi gets cancelled on the left and right, r square is 81. So they are basically telling you that the radius of the circle is 9. Okay, with r being 9 centimeters, you have to find the length of arc subtending an angle of 300 degrees at the center and also the area of the corresponding sector. So theta being given as 300 degrees, let's write that 300 degrees in radians. So 300 degrees in radians would be 300 into pi upon 180. 6 3s are and 6 5s are. So we have theta as 5 pi upon 3. And now what we need is the length of arc, that would be r theta. R being 9, theta being 5 pi by 3. 3 cancels off 9 and S becomes 15 pi centimeters. So the length of arc is 15 pi centimeters and area of the sector, that would be half r square theta. That is half r square being 81 and theta like we got is 5 pi by 3. So the area of the sector is 3 cancelling of 81 and you get 27. We have 27 into 5, that is 105 pi upon 2 centimeter square. So that's the area of the sector, and this are your answers for question number 7. Let's go ahead in a similar way with the 8th question. And we have we have to show that the minute hand is gaining 5 degrees 30 minutes on the hour hand in 1 minute. Many a times, many students feel that this question is not clear. It simply tells you that you have to show that in 1 minute, the minute hand is going to trace an angle which is 5 degrees 30 minutes more than the hour hand. Okay, so in 60 minutes we know that in 60 minutes the hour hand is going to cover an angle of 30 degrees. So in 1 minute the hour hand is going to cover 30 upon 60. Basically that 60 just goes here. So in 1 minute the hour hand is going to cover 30 upon 60, which is half a degree, and half a degree basically means 0.5 degrees. 0.5 degrees means 0.5 into 60 minutes, and 0.5 into 60 minutes would mean 30 minutes. So in 1 minute the angle traced by the minute hand would be 30 minutes, and let's have the same calculation for a minute hand. In 60 minutes, minute hand covers the entire circle. That is, the minute hand covers 360 degrees in 60 minutes. So in 1 minute, the minute hand is covering an angle of 60 goes in the denominator. So we have 360 upon 60, which is equal to 6 degrees. So the minute hand covers 6 degrees in 1 minute. So in 1 minute, the angle traced by minute hand would be 6 degrees and the angle traced by hour hand would be 30 minutes. So the extra angle traced by the minute hand is 6 degrees minus 30 minutes, or 6 degrees minus half a degree, that is 5.5 degrees, or 5 degrees 30 minutes. So that's all you had to show in the 8th question. And with these calculations it is very much clear that yes, the minute hand covers an angle of 5 degrees 30 minutes extra than the hour hand in 1 minute. 3 last questions for this video. The first one, which tells you that a train is running on a circular track of radius 1 kilometers at the rate means the speed of 36 kilometers per hour. 36 kilometers per hour, you need to understand what that speed is. 36 into kilometers per hour, right? 1 kilometer is 1000 meters. So I write it as 1000 meters in the numerator, and hour was in the denominator. 1 hour is 3600 seconds. So that 3600 we can write it here. So now 36 cancels off 3600, giving you 100 here. 2 zeros get cancelled up and down, and finally we can say that the speed given to us is 10 meter per second. Okay, so the train is moving at 10 meter per second, and find the angle to the nearest minute through which it will turn in 30 seconds. Let's not go up to the nearest minute, let's just find the angle in whatever easiest form we get, and we will then go ahead with the next question. The time given is 30 seconds. So at a speed of 10 meter per second and in a time of 30 seconds, the distance traveled is going to be speed into time, that is 10 into 30, which is equal to 300 meters. And that distance is basically being traveled on a circular track. Okay, so the distance traveled 300 meters. Let's say that's the train moving on a circular track. It's traveling 300 meters. And the radius of the track is 1 kilometer, that is 1000 meters. We need the angle traced, right? So theta, we know that S will be equal to R theta, S being 300, that is the length of arc, R being 1000 into theta. So we get the value of theta as 300 upon 1000. Cancel off the zeros, you have 3 upon 10, that is 0.3 radians as the measure of the central angle. To convert this into degrees, you simply multiply with 180 upon pi, but because the calculation will be a little complicated, I am just leaving it here. The idea is to just know how to reach a particular answer. Other than that, the calculation and all, of course it is time consuming, but it is something which most of you can manage. In a circle of diameter 40 centimeters, that is radius is 20 centimeters. The length of chord is 20 centimeters. So, okay, the length of chord is 20. Find the length of minor arc of the chord. So that's the circle. And the length of a chord is 20. And the radius is also 20. So if this is 20, 20, and this is also 20, you need to understand that it's an equilateral triangle. And the angle at the center would be 60 degrees. You need the length of minor arc. That is, you need this particular length, and that length of arc will be given by S equal to r theta, where r is 20 and theta is 60 degrees, but we need to write that in radians. So we convert 60 degrees into radians with multiplying by pi by 180. 60 into pi by 180, that would be pi by 3. So 20 into pi upon 3, that's simply 20 pi upon 3. That would be the length of arc of that given circle. So 20 pi by 3 is the answer for the 10th question. And finally, one last question in this video. The angles of a quadrilateral are in an AP. Find the greatest angle if double the... the greatest angle is double the least. It's here. The angles of a quadrilateral are in an AP and the greatest angle is double the least. Find the angles of the quadrilateral, but the measures of those angles, we need them in radians. Okay. So let's take the angles of the quadrilateral as A plus D, A plus 3D, A minus D and A minus 3D. Okay. So these are the angles of your quadrilateral. If you add up all these angles, the total should be equal to 360 degrees, because that is a property that the sum of all angles of a quadrilateral will be 360 degrees. Add them up. You have 4A is equals to 360 degrees. So A will be equal to 90 degrees. They have also said that the greatest angle, which is A plus 3D, is the double of the least, that is, it is 2 times A minus 3D. By solving this condition, we will get the value of D also, because A value is already known to us. So let's solve that condition. On the right, it will be 2A minus 6D. You can take A on the left and you can take that 6D on the right. So you can take A on the right and minus 6D on the left. So that should give you A as 9D. A is 90. So D would be 90 upon 9, and that is why we get the value of D as 10. So if D is 10, A is 90, we can simply write the angles of our quadrilateral. A plus D would be 90 plus 10, that is 100, all in degrees, okay. A plus 3D, that would be 90 plus 30, which is 120 degrees. A minus D, that is 90 minus 10, which is 80 degrees. A minus 3D, that would be 90 minus 30, which is 60 degrees. So these are the angles of your quadrilateral. Let's not solve it completely because all of it is quite mechanical. I'll just tell you the method. Just in case you want to convert 80 degrees into radians, you multiply that with pi upon 180 and you have the angle 80 degrees converted into radians. That would be what? 8 pi upon 18, cancel off a 2, so you have 4 pi by 9. Okay. So 4 pi by 9 radians is one of the angles. Similarly, you can convert every angle into radians by multiplying that angle with pi upon 180. That's the end of whatever I wanted to discuss in this video. I hope whatever I've discussed has been somewhere helpful to you in your preparations. Thank you for watching.